Good evening. Thanks for coming. I'm Kurt Asher. I'm Dean of the Library, and tonight we're here to talk about alternative energy and its potential. This topic has some resonance for me because my son has been a project manager on several wind and solar projects in Eastern California, Texas, and Mexico. So when I heard that William Kamkwawamba, sorry if I stumble over his name, and the book, The Boy Who Harnessed the Wind, was going to be our reader this year. I was really looking forward to hearing him, and I want to thank Emerson for picking that book, actually. And also, I want to thank Emerson for helping me set up tonight's event as well. So thank you, Emerson. Tonight, two of our campus's top economists are here to talk about the potential of wind and solar energy. Dr. Aaron Hegde is the chair of the economics department and director of the environmental resource program. He's also a professor of economics who holds a PhD from North Carolina State University. Our other expert tonight is Dr. Nyakundi Micheka. Am I right? Did I get it? Yeah, okay. Mitch, right? He's an assistant professor of economics and a very active scholar and thinker. He earned his PhD at West Virginia University. So let's welcome our guests.
Greetings, ladies and gentlemen. How you guys doing? Wow. Okay. You guys saw half my slides, but that's fine. So today we're going to talk about energy production and consumption in Africa. And what I'll do is I'll start from a very basic level, and hopefully by the end of my talk, you'll be able to understand what's going on in Africa. So the first thing is this. So usually, when you wake up in the morning, what's the first thing you do, apart from open your eyes? Pardon? Check your phone, go to the bathroom, turn on the light, right? Take a shower, those of us who shower in the morning, right? Hopefully the water is warm. And then get your clothes out of the closet and iron them. Probably go to the kitchen, get some breakfast, probably use the microwave. If you're having yogurt and granola, you need something that's cold. So there's a fridge that has been keeping things very cold for a long time. And then you probably boil an egg, and then you get into your car and you drive to work, right? Now, as I talk about all these processes, I just want you to think about all the energy that's used to do the things that you're doing, right? So from your phone to your radio, to boiling that egg, to the microwave, to driving to work. You get into work, you turn on the lights, the building is probably cool or probably warm, right? Something has been keeping that warm. You turn on your computer, you work on that, and then if you're taking vitamin C pills or you're taking some medicine, that stuff too is a petroleum product. Then, you get home and you watch a movie and you do that. So energy is everywhere. Right? Even the clothes you're wearing, even the shoes you're wearing, the seat, the phone, the pen that you're holding right now. We come across energy across very many places in life. So this graph right here talks about where energy comes from and how it actually ends up. Okay? So all the way on the extreme left, you have energy from solar, nuclear, hydro, wind, geothermal, natural gas, coal, biomass, and petroleum. And all of that stuff somehow comes into the system. Some of it is used to generate electricity. And then another bunch of that goes into residential, commercial, industrial, and transportation. So energy is everywhere. Different forms of energy are used to produce different type of things that we use, different type of energy services. Okay? So that's typically how things are. Now that we see how energy is part of our life, let's go to Africa for a little bit. And people like asking, when are you going to Africa? When are you going to Africa? And sometimes I don't like that question because Africa is a big, big place. Okay? So if you were to look at this map, there are 7 continents, and Africa is right smack in the middle. It's that orange section. And if you were to dissect that, there are a couple of things that are going on in there. Okay? In fact, let's now look at the satellite images of Africa. You can see that the map on the left shows you that the northern part has desert, even the southern part, and then the central part has equatorial climate, a lot of green. And then the map on the right side shows the administrative boundaries in Africa. How many countries are there in Africa? I think there are 54, okay? I think there are 54, okay? And there are about 1.2 billion people there, okay? So, and the size of Africa is roughly the size of the US, India, China, and Europe combined, okay? You put all that stuff together, you get the size of Africa. 54 countries, and then if you're to look at independence, that thing, it says 58 years old. A lot of these countries got their independence in the 60s, okay? When did the US, what year did the US get its independence? 1776, right? A lot of you are saying that, which is a long time, right? So you have someone you have a country that's had its independence for that many 200-something years, and you have a bunch of countries whose average independence or average year of independence is since the 60s, so it's about 60 years old. And then if you are to take this whole chunk of Africa and you break it down, you have the northern part, you have west, you have Central Africa, you have East Africa and Southern Africa. Same way we look at the north, south, east, and west in many parts of the world, okay? So let's talk a little bit about culture, okay? Now, before I go, let me see here. This gentleman right here, what's your name again? Edgar. So Edgar, think about this. Edgar, if think about you as a person, you come from a family, they're probably, let's think of you having 1.2 million who speak the language you speak. Okay, there are 1.2 million who speak the language you speak, who eat the type of food you eat, who have certain culture that's associated with you. I talked about language and come from a particular part in a country, okay? So there's 1.2 million of you. And then you go to Lindsay, and there's like 12 million. Lindsay's like, why are you pointing at me? 12 million of them. And then you keep going this way, and you keep going. So if you look here, I'd say I can take 42 of you, okay? So those are 42 different cultures, 42 different languages, 42 different types of people who come from maybe a country called Kenya, okay? That I just described is right here. You see this big blue thing with 12 million and all that stuff, right? That's Kenya. So that's one tribe, and then all those other little bubbles and blues and greens and nice and all those colors make up different tribes. So you have 42 tribes which fit into that big gray thing, okay, which is one country, okay? And that country has 40 million people. So 42 tribes, 40 million people, that's one country. And then you take that one country and that gray, now those are other countries. Those other grays are very many other countries. And you make 54 of those, okay? Now, these people have different ways they use energy, the different cooking styles, the food they eat, the traditions they have when they're going to get married. Everything is different, right? And these two folks, if you speak in your native language and you speak in your native language, you might hear one or two words, but chances are that you won't hear a lot of stuff, okay? So very, very diverse culture. That's just one country. So getting back here, all these, man, this is so tricky. Sorry about that, guys. So all this I just described is one country. Okay, now let's talk about the economy. Now, if you look at, there are very many countries. I remember we said there are 54. The largest two economies in Africa are Nigeria and South Africa, okay, in terms of GDP. The next thing that you want to think about is what drives the economy. Well, agriculture is usually the largest driver of the economy in most countries in Africa. And if you were to look at how these countries have been growing in terms of the economic development, between 2000 and 2012, sub-Saharan Africa countries almost doubled the economy. That's a lot, like doubled, right? The size of the economy doubled. And then if you're to think about energy, Africa is very rich in energy resources, but it has a challenge. It's poor in supply, okay? And I'll talk a little bit about that. Remember, these countries are on average 58 to 60 years old, okay? So this is a country that's trying to put a bunch of things in place so that things can work going forward. Rwanda and Ghana have seen a lot of successful electrification rates, and energy demand, right? Demand for energy has grown by about 45% from 2000 to 2012. So in 10 years, we've seen energy demand grow by 45%. That's having someone, right, like Shelby. Shelby moves from the rural areas, moves into the urban areas, and now she wants to buy a car, she wants to buy a microwave, she wants to buy a fridge, she needs to charge a phone, she has an iPod, iPad, she has a bunch of... So this is happening with Shelby, but there's a ton of other people doing that, and this is happening in very many other countries. So that's why you're seeing a lot of energy demand increasing in that manner. In terms of power, a lot of energy comes from coal, okay, and South Africa is a large producer of coal. That's why I've put SA in parentheses. 22% of energy comes from hydroelectric power. When I talk about hydro, what do you guys think about? Water, aqua, right? Water, right? So you take water, you put you have a river that's flowing. Okay, now I'm showing you one form. You have a river that's flowing, you put a big dam, okay, and then you trap the water, and then the pressure that's coming and flowing through turns a bunch of generators. And once you turn those generators, you generate electricity, okay? That's what we're talking about here with that. When it comes to coal, that's another whole story. You're taking coal and you're burning it, and the water that is being burned produces steel, and that steel goes and turns turbines, okay? Oil and natural gas. So in short, you can see how a lot of the energy is produced and generated in Africa. Now, this map here talks about folks who have access to electricity. Now remember, these countries are about 60 years old, okay? So the graph or the map on the left shows, percentages of people without access to electricity. And then the one on the right kind of just simplifies everything, okay? But this number, ladies and gentlemen, is changing. If we were to draw this in about 5 or 10 years, we'd have a totally different scenario because there are a lot of things happening, and I'll talk a little bit about them. As of 2014, 620 million people were without access to electricity, but things are again changing. Here we're talking about the grid, but there are other mini grids or solar systems that people are setting up in their homes that are changing some of these scenarios. Remember I talked about having many energy resources. The graph or the figure on the left, why do I keep talking about graphs? You guys have me all graphed out, right? Anyway, whatever. So the image on the left shows all the fossil fuel resources. You can see there's a bunch of oil in a lot of places right here. And some of these are relatively new discoveries. These things showed up in the last 5 years. So remember, discoveries are taking place. So there are things that will be populated here with time that are not here right now. Coal, South Africa is known to produce a lot of coal and use a lot of coal. And with regards to natural gas, Mozambique, which is a country that's right around here, produces a lot of natural gas. Wind resources, you can see they're at the top and all the way at the bottom. Solar, very many places, okay? Usually before you install solar, you want to know where the sun shines the most. So a lot of energy companies put out maps that show areas that have a lot of sunshine, okay? So this is just, it's a general picture of what's happening across the country, or rather across the continent, but this shows you my clicker. Guys, the clicker, the clicker, this guy. I'll just stand right here. Yes, sir. Please, or whichever works for you. So we need to go back up one more. Yes, okay, hydroelectric power, big issue. So you can see what's going on right here. So there's a lot of, this is the green part of the map. You remember the green part? There are a lot of big rivers and lakes that are in this part of the country. But remember, each of these is a separate country, okay? Meaning, some places you need a visa to go to the next country. They speak a different language, they have a different political system, everything is very different, okay? So even if I may have access to a lot of renewable energy, or I can put up a dam here that can produce electricity that can supply all those places. Well, there's some geographic and jurisdictions that we cannot be able to sell things that way. Do you guys know what the name of this little blue line there is, or that river? The River Nile. Good. Did anyone read the paper today, or know what's going on with the River Nile and Ethiopia and Egypt or Uganda? Anyone? Is there hope? Pardon? Anyone? So let me tell you something which is pretty interesting. So where does the River Nile start? Or where does it originate from? Or does it flow like that or like this? Based on that map. It goes up, right? So, and you know that it supports a lot of people who live right around here, okay? So if something was to happen right here, It would block a lot of things that are happening on that side, right? Now, remember I talked about hydroelectric power generation. Some of these countries like Ethiopia and Uganda, actually Ethiopia, is currently in the process of putting up a dam right here. The dam will provide electricity to very many people around here, but it threatens the livelihood of people who live around up there. Do you guys see that? It's a catch-22 situation. So what do? Do we go ahead and get electricity, or do we not get electricity? So that's a big thing that's going on right now. Anyway, that's a story for another day. Next, thank you. So nuclear energy. Do we have nuclear energy in Africa? Yes, we do have some parts that are developing, or rather in consideration. Okay, so let's start with orange. These are some in consideration, some are developing, construction, and operational. So we only have nuclear dams or nuclear power plants operating down here in South Africa, and then there are discussions that are going on in those other regions. So we're looking at very many forms of energy here. Photovoltaic power potential, if you were to install solar, you would want to put your solar power plants where it's very, 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 very red. You guys see that? The reddest parts are the ones which have a lot of solar energy potential. So in Africa, you can see what's going on, and then you can also see where we're at, okay? So this map shows you what the potential is at. Next. So generally, if you were to look at an overview of what's going on in Africa, remember there are 54 countries, there's so many things happening in each jurisdiction. But generally, bioenergy is at the heart of energy mix. Hydropower, there is large potential. Some places are developing this fuel energy, but that's something that's still being done. Oil, Nigeria produces a lot of oil. It's part of OPEC. And we just discovered some oil in Angola. So there are discoveries that are taking place. Natural gas is also produced in Nigeria, and coal. When you talk about coal and Africa, usually South Africa is synonymous with coal in Africa. So they're producing a lot and they're consuming a lot, as you can see right here. So if you were to look at this now, what you can see, remember that map, there's a map that chopped up north, south, east, west, central, and all that stuff. This graph does the same thing, okay? But it shows you where all these energies end up. Green means industrial, so a lot of the energy that's produced in Africa ends up with industries, and then you can see residential areas, the purple, and then there's the gray and the blue. But you can see that West, East, and Central Africa typically do not consume a lot of electricity. Okay, but this is a number, again, that's going up. In terms of trade, a lot of the oil that's produced in Nigeria is exported. We also have a lot of energy that's exported in the southern part of Africa. But as I mentioned, there's a lot of coal that was just discovered in Mozambique. Oil exports. Kenya just started exporting oil a few months ago. Okay. Now remember, this map is 2012, but this thing will be updated. And then there's natural gas that were discovered in Tanzania and Mozambique. Large resources. So these maps change so much. They're changing really, really, really fast. So looking ahead, now these are things that we need to think about. First, there's a lot of rural to urban migration. Okay. Remember, these countries are about 60 years, and they're very, very many. 54. So most of these countries, some reports have said that the economies of most of these countries is set to quadruple by 2040. Okay, 2040 is about 20 years from now. Quadruple, 4 times, okay? Energy demand is set to rise by 127%, according to the BP Energy Outlook. And then population growth is also taking place, okay? So people are living longer, and with people living longer, you have more people around for a longer time. And in addition to that rural to urban migration, we're going to see a large number of people living in cities and needing a lot of energy to work with. 63% of the population is in rural areas, and that is also set to affect pollution. Are you guys okay, first of all? You guys are so quiet. What's wrong? You're like, you saw me yesterday, you're seeing me today, you'll see me tomorrow. We're like, oh gosh, what a long week. Oh, it's okay, it's a discount. Today you learn about Africa, okay? Okay, so the other thing is this, pollution. Now, I'll talk a little bit about that because that's very, very serious and very, very important. If you have a country that has developed, okay, that has moved from a certain level of development, used a bunch of energy, and is at a certain point in development, there's some pollution that comes with that process, okay? And, there are folks then there are other countries that are coming along that way, right? So the way the discussion that people are having right now regarding pollution and how this should be distributed, especially in countries which are seeing a lot of development right now, is a contentious issue. Okay, some countries are saying that, well, we should be allowed to pollute like our neighbors because they did the same in getting to where they are right now. Right? In fact, if you go to the next slide, you'll see that cumulative, if you look at the CO2 carbon dioxide emissions from 1890 to 2012, compare those charts right there. You can see that the US has about 350 gigatons, and there are countries right there. You have India, you have Middle East, and Sub-Saharan Africa. Okay, and these guys, they're going to develop. Everyone wants a cell phone. People want to be on Snapchat or Instagram, right? I've become, I don't know, we talk about Instagram a lot. Followers. You guys remember the followers joke? But Sub-Saharan Africa, that number is set to grow. So things are happening. And then if you go back one slide, Aaron. One. So a lot of things are happening right now. There are a lot of policies in place to provide access, okay? So remember I talked about earlier on there were 620 million people without access to electricity in Sub-Saharan Africa is that chunk at the bottom, okay? What's the population of the US? Like 300-ish, right? 300 million. Now, 620 million is how many USs? 2, right? So they're trying, now there are plans to provide electricity access to all these people, okay? You guys see what's going on here? So those policies that come into place need to take care, or they need to cater for pollution. And the good thing about some of these policies is they are looking to find more efficient ways to provide access and have more efficient buildings, especially those which use renewables in an efficient manner. Okay, now we can go ahead. I think we've seen this. And then what I did is I just said, well, let me just do a Google search of some of the headlines that we're seeing today. So typically, this is what you come across. A lot of countries are putting in place measures to provide electricity to very many people in a very efficient way. South Africa is looking to add 10 gigawatts of renewables by 2050. Zimbabwe has just installed 39 solar power projects. The African Development Bank said they're not going to fund any more coal-fired power plants, right? Or coal-related projects. That's not happening. Burkina Faso is also looking to put solar panels in the Sahel region. And then Russia is currently in talk with many countries to develop their nuclear power plant. And then in Morocco, you're seeing the energy efficiency plans are set to create 150,000 jobs by 2030. And this can go on forever. Oh, and that's the references. So the only thing I want to say is this. As we look at the situation in Africa, there are 54 countries, right? I've said this so many times, I think you'll remember that. They all have different policies, they have different climatologies, they have different cultures, and a lot of the policies they're putting in place are independent to what's going on in the neighboring countries. That's different from what we have here, because here you have maybe a number of states can come together and create a cluster and have an efficient way of producing electricity in one place and transporting it to the other place, or selling it to the other place. But a lot of what we're seeing here is we're still developing. So a lot of what I just talked about is going to change, and it's just something for you guys to think about. That's all. Thank you.
Good evening. It's always hard to follow Dr. Michega, and it's even worse when you're under the weather. So I'll do my best. He's been talking about Africa. So I would like to bring you back to Kern County. We'll look at stuff. So the title there, when we were setting this panel up, Dr. Case over here asked for a title. He sent the email to both myself and Dr. Michiega, who was traveling in Kenya at the time. So nobody responded. I thought he will respond. He thought I will respond. And then I got an email from Dr. Case that I need a title right now. Couldn't think of anything, so came up with Wind Beneath My Wings, which he hadn't heard of before. He Googled it, And he came up to me and goes, "This is a funeral song." I told him, "No, it's a wedding song." Maybe the same thing, I don't know. So it came up with a different title, "Blowing in the Wind," which maybe some of you might know. It's from a Bob Dylan song. And this will be the last time I'll come up with titles. So anyway, so that's what this is. So talking about Kern County. So one of the things, how many of you have read the book, "The Boy Who Harnessed the Wind"? Those of you in my class, you better read it. The paper is due soon. There's also a movie on Netflix, but you need to read the book for the class. So in the book, for those of you who haven't read it, it's a story about this boy in a village in Malawi, which is where? East Africa? Yes. And there's drought and all the famine and all this stuff, and he gets kicked out of school, and he is very inquisitive. He wanted to go to a good school and stuff, but he wasn't able to get in because the family couldn't afford it. So he tries to do something useful for the village. And one of the things he does is reads up on these books he's always been tinkering with radios and things like that. And he finds a book on science, and then he tries to build a windmill from discarded parts and stuff so that he can have some energy to draw water for the village, which is important, and then electricity to run a few things here and there. So it's a good story about the ingenuity of an individual, the hard work, and being able to do that, which is great, but all the stuff that Dr. Micheka talked about requires scale. Scale means large production. So individual production versus large production. So this map that you see is a map of all the counties in the United States that produce energy using wind, turning wind into energy. Okay, so the way they do that is using this thing called the wind turbine. And what you'll notice here is a pullout on the left-hand side is that Kern County is number one. So Kern County is the county that produces the most energy using wind. In fact, you'll see the number. It says 4581. That's how many wind turbines there are in Kern County. What's number two? Riverside County. And if you look at their numbers, 2,300. And number three, and this is not just in California, this is nationwide. Number three is at 1,430. So we've got a lot of wind energy produced here. So what is wind energy? Well, it's part of this thing we call renewable energy. Most energy comes from, as Dr. Michiko was talking about, either coal or petroleum, which are all what we call fossil fuels. These are non-renewable, because once we use them up, we don't have them anymore. The other part of this is fossil fuels also lead to pollution, which is also something Dr. Michiko mentioned. And you can see there's a correlation between economies that grow and develop and the demand for energy. And if they use it from these non-renewable sources, then that also adds to pollution. So wind energy is renewable because there's always wind. But the problem with wind is it's not everywhere, right? Some people say there's a lot of hot air in university, but that's not the wind that we're talking about here. That's mostly in our department. This is another map of California and all the wind energy that's generated in California. It's a three-dimensional map. The basic idea, what you see in the middle, in the big blue circle, that's right here in Kern County. So when you drive up to Tehachapi, all the wind turbines that you see, most of it is that. So those wind turbines generate enough energy along with the rest of the area in Kern County to make it the number one county for that. So some of these things, so obviously what's important is wind. You can't have too much wind or you can't have not enough wind. So you need to have the right amount of wind, which is what we have. And that's what you see on the left-hand side of this scale. The color refers to this wind speed. So this is another map by county throughout the entire United States. Overlaid onto this is the wind speeds. So when you see Kern County, which you may or not be able to see, which is this Kern County right here, And you see most of this is this pink color. That's the optimal wind speed. And that's what we have in Kern County. We have wind, and it's the good amount of wind, which allows for us to generate these things. So how much do we generate? What are we talking about here? Here are some facts. Not only do we have the most wind turbines in the US, we have the highest turbine density in the world. Given the amount of space and the amount of turbines we have, so that's according to the US Geological Survey. So they actually have a map which maps out every wind turbine in the US. So you can go to their website, USGS, and you can see where all the wind turbines are. So that, again, as I said, number one in the nation, even in terms of density, the biggest in the world, and generates 4.2 megawatts of energy. For most of us, it doesn't mean anything, right? You hear that, okay, sounds like a good amount, whatever that is. But basically, it's enough to power 1 to 3 million homes. So think about that. Okay, 1 to 3 million homes, energy. So what exactly is a wind turbine? The basic idea is pretty simple, and it's been around for millennia, going back to like the 1st century AD, where people had this thing. Now, this is different than a windmill. All the windmill stuff that you see in Denmark and all the other places, that's different. That doesn't produce electricity. It's used for mechanical purposes, to move machinery and things like that. But the wind turbines that we're talking about are the ones that the wind turns the propellers, and that results in the motors being turned. I'm not an engineer, so I'm going to try to explain it the best I can. And the motors turn, and the action of the motors, so it goes from kinetic energy to electrical energy. And then that gets stored, and then that gets shipped out to the grid, which is typically owned by one of these producers. So, as I said, it depends on the amount of wind you have. To get it started, you have to have at least 6 to 9 miles per hour. But if it's more than 55, that's too much, and the wind turbine shuts down, because that might blow out the circuit and things like that. So it has to be that optimal. So you can't be in an area where there's too much wind. Now, we are all familiar with the impact of wind on power, right? PG&E has started this thing where in any area which is dry and windy, what are they going to be doing? Shutting it off. So even as an aside, even if you have solar panels on your house, you won't have power either, unless you have a battery. And that's the crux of this problem, is the ability to store energy. You need to have a battery to store energy. So most of the solar panels, if you don't have an energy and the battery, and the batteries are made by Tesla, so you can buy a battery to put in your house that would store the energy. But most solar panels generate the energy and ship it back to the grid, the electricity grid. And that's another important thing. We'll come back to that. And then when you need it, you draw it from the grid. So you still need PG&E because they're the ones controlling it. So if they shut it off, you can have solar panels, same thing, you won't have power. If you have a wind system in your house, which you can, still be the same thing, unless you have a battery to store it, okay? So the thing about wind, it's a relatively cheap source of energy production. So here's a chart which shows you roughly the cost of energy production based on the source. So the top in blue are alternative energy or renewable energy, and in the black, conventional or what we call fossil fuel-based energy. So you can see, obviously, coal is pretty cheap, gas is pretty cheap, nuclear is up there, but if you look at in the top part, and you can see wind right here. Now, with technological improvements, wind energy has become cheap. In fact, there's also a lot of more technological advancement, so the solar panels have been costing less with the tax credits and things like that, so you'll see that cost also decreasing. But wind is one of the cheapest source. Coal is still cheaper, but in California, we don't use a whole lot of coal. It's used where Dr. Michieka came from in West Virginia. That's all, everything is run based on coal. Again, going back to this idea of pollution, right? So with wind, we don't have that problem. So what is the problem with wind? Why don't we all use it? Well, A, you have to have the wind, the right amount. And some people think, well, it causes cancer. No, it does not. Okay? Wind turbines do not cause cancer. No matter where you've heard it, people living near it, never been any instance of it causing cancer. It does have some environmental impact in that some birds run into it. So there's some birds that die because of that. But there's some modern technology which actually sends out this sonar signal that tells the birds not to come near there. So looking at this source, oh, you can't see that. But where does our energy come from then? Well, again, on the second column is in the U.S., and the last column is California. And it's hard to find this information for Kern County. I looked everywhere, and I couldn't find it. But in the U.S., 13% of our energy comes from coal, 2.2% comes from hydro, 31% from natural gas, 11% from renewables, part of which 2.2% is wind, and then 36% from petroleum. So when you look at the petroleum, add to that coal, those are very high polluting sources. Plus, they're fossil fuel, so when we run out of it, so at some point, we need to make that transition. From an economic perspective, societies make that transition when it becomes cheaper. Most societies only look at the cost, what it costs them to buy that stuff. They don't take into account pollution costs and all those other things. If you include pollution and the cost that pollution has on society, then actually all the renewables are much cheaper, right? Because when you have, as was shown earlier, all the CO2 emissions, carbon dioxide, that leads to greenhouse gases, which then leads to climate change, all of those things. So California, on the other hand, a little different than the US. California, 3% only comes from coal, mostly because we don't have any coal deposits in California. So the coal we get has to be imported from somewhere else. 11% from hydro, 35% from natural gas. So it's similar to the US, but the big difference is in the renewables. And in the last few years, that's where California has made the big advancement. Solar and wind. Wind is about 11% of all the energy used in California. The source is wind, and petroleum is 0%. So, big important difference is California is renewable. So when we talk about the types of wind energy, so why not just have them everywhere? Again, as I said, you need the optimal amount of wind. And there's 3 different types that you can have. You can have the large utility scale, and by large we mean these generate more than 100 kilowatts. That's the ones that you see in Tehachapi with the big blades and stuff. And they generate the electricity. It's connected to the grid, and then the grid sends it out wherever it is. The problem with electricity is it doesn't travel well. So if you produce, for example, in the state of Kansas, there's enough wind blowing there, and if you've seen Wizard of Oz, you know that, right? There's enough wind blowing there to power the entire country. But the problem is getting it from Kansas to everywhere else. The grid, or the transmissions, as we call it, is old. So a few years ago, they tried to spend money on updating the grid to modernize it, but it wasn't very fashionable, and it never got anywhere. So our grid is super old. Africa, countries, 58 years old, our grid is over 58. It's older than that. So it's hard to move electricity from one part to the other. So the other is a small scale one. You can put a wind turbine on your house, and that could generate enough, less than 100 kilowatts, to power your house. And you can have it such that it's not connected to the grid. So in that case, if it's not connected to the grid and you have some ability to store it, when PG&E shuts off power everywhere else, as long as there's wind, you will have that. But again, there's issues with timing, right? As there are seasons, wind also is different in winter than it is in the summer, than it is in the spring. Excuse wind is also different during the day, evening, so when you need it, so there's a lot of those kind of issues. But they have the technology now such that it's about 2 to 4% less reliable than the regular electricity that you get, which is marginal, right? So the technology is there to be able to put wind turbines on your house to get the energy from that. And then, of course, the other one is the offshore. The problem with also wind turbines is a lot of people think they're eyesores. They don't want to see this giant windmill-looking kind of things, wind turbines in their backyard, not in their backyard type of thing. And a lot of people don't want it offshore either. So offshore means they're located in the ocean, not in the ocean, but they're I don't know, they're planted in the ocean, whatever. And the wind generates, they generate power, and then they can ship it. And again, there's enough wind offshore to generate the entire country, but the problem is with the grid. So ultimately, it comes down to feasibility is based on, I had a chart, oh, there it is. So this is the transmission lines in California. And what you see here, the red lines are PG&E, which is most of them. The blue is Southern California Edison. Let's see. And then the others are the smaller ones, regional ones. But those are the two big ones, Southern California Edison and PG&E. Now, if you remember, the wind stuff is generated right here in Kern County. But if the grids are not there, you can't get it from Tehachapi to elsewhere. But in Kern County, the wind that's generated, the wind energy that's generated in Tehachapi powers about 14% of Kern County. So it's more than the state of California, which is about 11%, and more than nationwide. So that's why Kern County is the wind energy capital of the world, according to the U.S. Geological Survey. Also, solar energy is another big one. But that's a discussion for another day, another bright day. So that's all I had.
Yeah, questions? Yes.
On the offshore turbines, how do they transport the electricity if it's far enough offshore to the grid? Do they run lines?
Mm-hmm.
Do they run lines underwater?
Yeah. Yes. Yes. Yes.
And there's actually Kern County, and it depends on who you talk to. But in general, one of the things that Kern County is known for is the rapid permitting process, and which depends on which perspective, where you stand, could be a good thing or a bad thing. Right? Rapid means you still have to do an environmental impact report and all these other things, but it doesn't get tied up in as many hearings and stuff that other places. So that's really one of the big reasons why we see so much renewable energy in Kern County. So whether it's solar or, one of the things is now that we're producing this much, to be able to send it elsewhere, storage. So that's the other thing that Kern County is working on, is planning, building more battery storage areas that you would have that would store the energy. And then, but again, as I said, you need to have a efficient grid to be able to transmit that.
Yeah.
It's like billions, almost trillion.
Yeah. Also, just to add on to what he said, so the way we use energy in a day varies. So in the morning, you'll find that a lot of us are waking up, using a lot of energy. So the demand that we need from the grid is a lot. And then we all go to work and, the demand reduces just a little bit, and then it tends to rise again towards the end of the day. So trying to balance that, it means that we need to have first baseline energy. We need to have that minimum level of electricity, which is produced by coal at all times. And then when demand rises, maybe we're all home in the evening, or probably there's a concert here in town and we need to set up a bunch of stuff. We need to now draw energy from either intermediate energy or peak energy. These are energy sources which need to be turned on and off relatively quick. And that's where the renewables come in. Natural gas is a good intermediate source of energy. And then we have also wind energy, which is good for peak energy. But that costs more. And I'm sure when you look at your bills, you may see that your bill shows, there are different rates for different times of the day that you use energy. So just, energy can be produced, but we need to balance. We need coal from here, we need solar from here, we need wind, and we have markets that, that know how to balance all that and send it to wherever it's needed efficiently. Okay.
That thing's called the duck curve, by the way.
Yeah, the duck curve, yes.
Mm-hmm.
Mm-hmm. Yes.
Yes.
So on your map, you showed the optimal wind speed. Looks like it's a really big peak area, but all of the wind turbines are actually on the top of a hill. Ones I've seen anyway.
Mm-hmm.
So you say Kern County is the prime optimal wind speed. Is that the whole county or is that certain parts?
Certain parts. I mean, so this is at the county level. So the data gets aggregated.
Yeah. The other thing about those wind turbines, if you go, you'll find that most of them are different. Some look small, some look really large, some look like they're standing on a cage. But as technology advances, you get more efficient turbines being put in place. And some are able to capture energy more efficiently at higher places and lower places. So that also plays a role.
That one's called the load factor, I think.
Yes.
Right? And so if the turbine runs 24 hours, it generates that's the capacity. But you're not always going to be running it because the wind's always not running. So it's the load factor. So it's usually 80%, 40%. So that's why it varies by day.
I think there was one all the way at the back. Yes.
Hi, thank you for this presentation. I'm Tony the Tech, and I work in the art department. And coincidentally enough, I'm building off the grid home in Tehachapi, one of the windiest places in town.
Yeah.
Okay.
I have to tell you though, there are other energy-saving equipment you can use. The simplest one is a 6-volt battery.
Mhm.
It's more maintenance, but it's not like your AC650 batteries. It's a lithium battery. But I can also tell you that part of this whole thing with sustainability is dealing with the government and trying to say, hey, I want to build a small house. It's actually dealing with straw bale house. And to explain it to the government is really a big thing because corporate government doesn't want us to build small homes. They want us to use regular 2x4s, regular fiberglass, and all that. But this is very interesting for the young folks here because who remembers growing up without any power? There was a time in my life living in Mexico where there was no power. It was just basically lights at night with a candle. So just remember that our ancestors 100 years ago, some of them didn't have power, and we're here because of it. So don't depend on this all the time. Cancel Lord is good.
Okay. All right. Okay. Thank you, sir. Kurt?
I don't know if I'm wrong about this, but I'm curious. In Africa, from what I've read or know,
Mm-hmm.
a lot of the projects there
Mm-hmm.
are small-scale solar projects, and I'm just wondering how the grid is connected from these places where they use like village solar projects, and then
Okay.
they're just it's really independently set up for that particular little village or town.
Yeah, so you're right. There's what we're seeing is a lot of governments come in with 10, 20, 30-year plans to spread or to provide electricity to a whole region. Now, during that time period, you may have some homes which decide to set up their own solar panel. And while that costs a lot of money, some decide to do that or purchase a generator. And it's gotten to a point where, because I know places from personal experience where they already have a solar panel, they have generators, and then, they've been living like that for about 10, 15 years, and now there's electricity everywhere. So it just depends. Some people can afford it and they can put it out there, but the government is now providing electricity, rural electrification, to very many places. So it's just a mixed, it's a mixed response based on that. Pardon? Say that? Attempt? Yes, there are actually some regional systems that I didn't talk about. Like I know Kenya and Uganda have, we sell electricity to each other, both countries, and because you can have a really large dam and a country has all this electricity that cannot be stored. So some of those things are happening. Ethiopia, so this is Kenya, Ethiopia is right at the top here, and there's a plan to build a dam right at the border, literally right at the border of those two countries, to put up a dam and generate electricity and sell electricity to both countries. But that, requires, cooperation, which is taking place, and in some places it's just taking a little bit longer. They do change, yes. Yes, Belen?
So Kern County is the capital in the world for windmills. Why is it that we don't have more positions, employment in Kern County in windmills? We don't hear, we have a windmill thing. We don't hear that as much. So if we were to switch to having more windmills and leaving oil behind, what would that mean to Kern County? I mean, employment. Do you have an idea of how much employment it contributes to the local economy? How much contributes to the local economy?
So there is, if you go to the Kern County Planning Department website, they have all the wind turbines that they've authorized, and it lists also the number of jobs that those creates and stuff. So obviously there's always, anytime you switch sectors or industries, there's always going to be job loss and job gains, right? In terms of how much jobs will be lost in the oil industry, I wouldn't know. Dr. Micheka would know that, but there will be some transfer. But the technology is also a little different, right? So you may not need, because with oil and electricity, they're two separate things. Oil is used for many things other than electricity too. Mostly it's used for gasoline, right? Which is separate than wind energy is used only for electricity. So I think there's a difference there in terms of scale. So I don't think it's necessarily one or the other. Now, if everybody switches to an electric car, then maybe things are a little different. But still, we use petroleum to make, as Dr. Michika mentioned, the first thing, everything that you see around you has petroleum in it, right? So, but.
Mm-hmm. Yeah, and just to add on to what he said, so when you set up a solar power plant or you set up a windmill, there are jobs created at the beginning, at the onset. They set up all these things and they put them up. But once everything is up and running, then you don't have a lot of employment. But we have energy, and we have renewable energy, and we have less pollution. So when you look at it in the long run, we just have to look at what do we value more. If it's employment, we're creating employment at the beginning. But for example, like the solar panels, we have Solar Star project somewhere in Tehachapi, and they say that they only need someone to come in and maintain the solar panels and make sure they're clean, and they actually have robots that clean the solar panels every now and then. As for windmills, these things are so smart these days. They, if the wind is blowing in a certain direction, they'll turn and face that direction. And, it can go around a couple of times, and then it'll probably switch off and say, okay, this wind is not good enough, and all these other guys are going to take over. I'm talking about little windmills, right? But, yeah, so that's just a long answer to your question. That man, Jorge had a question.
A lot of things with windmill is there's a thing we say in environmental economics. It's called NIMBY, not in my backyard. And for many people, windmills are an eyesore. I mean, if you don't see them regularly when you're driving by, you might think, oh, that's a nice, I'll take a picture, postcard or whatever. But for the most part, people don't want that in their backyard. So I think that's one thing. And two, most of Bakersfield is already so urbanized, and you need some space, and it can't just be, unless you put it on your house and doing that. for the industrial scale, you'll need a lot more space. Even though they don't necessarily cause cancer, but they have to be safe. People can't be going near there, and there's electricity generated. So I think that's why it makes it more challenging. So solar is a better option because you can put it on top of roofs, you can put it on top of parking lots.
Yeah. Did,
Say that again, sorry? No, I'm not saying that. I'm just saying that's the choice that the city is making.
yeah. Did you talk about pollution? Yes. So what was your question regarding pollution? Okay, yeah, so with pollution, it's a little different. The reason why, when you talk about pollution, you got to look at what causes pollution. There's particulate matter, those little, 2.5, 10, all those little particles. You have NOxes, nitrogen oxides, and carbon dioxide. You have a lot of chemicals that cause that. And those are caused, here we have an ag. We have a very big ag community. So when you talk about particulate matter, you're talking about those dust particles. Now, it would be nice if we had no mountains surrounding us so that the air would come and just blow and take everything away. But geographically, we are surrounded by mountains, so it takes a little bit longer for some of those things to dissipate and get dissolved into the atmosphere. We also have the 99 that drives right through here. It's the corridor of California. So many cars and trucks drive from the north all the way down to San Diego. And then there are very many other reasons that drive pollution. So those are some. Even when you put gas and a few drops of that gasoline falls on the ground, there's some emissions that are produced, but those don't get dissolved quickly as they would in a different place because we don't have that much wind.
So to add on to that, the direct answer to your question is the pollution is not caused mostly by energy production. The pollution is our daily activities.
You mentioned earlier that all you have is storing energy. You also mentioned Tesla batteries. Do you know if that's something that is required? Sorry, do you know if that's something that it comes with solar panels on top of your home, or is that something that you bought individually?
You have to buy them separately.
Do you know if it's subsidized?
I'm not sure, but the subsidy on the solar panels, it's a declining subsidy. So this year, I think it's 28% or 32%, and next year, it's a few percent less, and so on and so forth. Right? Kind of like the tax credit on the hybrid vehicles and the electric vehicles and stuff. So along those lines, I don't know, there may be a subsidy in battery, but I'm just not aware of it, because it's pretty expensive to get a battery for storage for your house, which is why it makes it more, because even now, even with all the tax credits and such, for the typical home, the median home in Bakersfield, you're looking at maybe $19,000 for installing the solar panel. So that means that your payback, depending on what your monthly bill is, could be anywhere from 10 to 17 years. So you add a battery on top of that, then the payback becomes even more.
So the production of wind it's also a real estate for
Mhm.
people who live in the country. I know in Texas, places like that. So these farmers, they're looking at, fairly make it each year, and when these companies come and put windmills on the property, now they have a lease that gives them several $1,000s a month. So that's one economic contributor. Not just in Texas, I'm sure that happens in California.
True. Yeah. That's true. Yes.
Bringing it back to stating the fact how Kern County produces the most wind turbines, and they only power about 14% of the electricity in Kern County. Where else does that electricity go? What else is it powering?
So it's a market. Usually, you have these, let me call them nodes. So you have a place in the West Coast which now controls electricity for about, let's say, 4 or 5 states. So what they do is they buy electricity from all these people who are willing to sell electricity to them, and then they send it to where it's needed most. So a lot of places like LA, for example, which have large populations, or industrial areas, those are the places that now that electricity is sold to, if they need it at the time. But that happens with those nodes that I call them, they're electricity markets. So there are about 5 or 6, I think, in the country, the PJMs and all that. But that's pretty much how it works.
The 14% is not what I meant. What I was saying is that the 14% of energy that's consumed in Kern County is generated by electricity. I mean, by wind turbines. Not 14% of the energy generated by wind turbines are used here. Do you see that distinction? 100% of the energy generated by wind turbines are used in Kern County, but that only makes up 14% of all the energy usage in Kern County. Is used in Kern County, yeah. And we also import energy from elsewhere too, from other states.
So wouldn't that be like substantial like business in Kern County, considering like we have like good quality winds and they essentially sell this electricity to like big cities like you were saying, LA or to San Francisco, San Diego, stuff like that?
Well, as Dr. Mishika mentioned earlier, you can't rely 100% on one source. It's an energy mix, so you need to have, because they're generated at different air times and speeds and things like that. So, of course, you can build more wind farms, which is what Kern County is doing, which is why we're number one. You can also build more solar farms, which we haven't looked at it, but if you look at it in California, the most solar energy is generated in Kern County. So in terms of, I mean, it's a nice, or maybe not, it's a contrast, right? On the one hand, we are the biggest oil-producing county in the nation. We're also the biggest renewable energy producer in the nation. So we're like definitely the number one energy producing county in the nation. So it's about the mix. Maybe at some point down the future, if somebody invents a battery that is transportable and all this stuff, we might be off of fossil fuels. But at least for the conceivable future, at least our futures and maybe yours, we won't be off of oil. The question is, when we do run out of oil, are we ready to make that transition? Or are we going to scramble at that point and then say, oh crap, we need to come up with something? Right? So that's really what we're talking about in terms of planning for the future.